All right, this is section 4.5, exponent rules, zero and negative exponents. I'm hoping this lesson is an easy one. I'm hoping that if you're paying attention, we should be able to get through this relatively quickly. Okay? So in multiplication, the terms that are multiplied together are called what? Does anybody know what they're called? Terms when they're multiplied together. Close. The product is the result of two terms multiplied together. When they're actually just multiplied, yeah?
Factors?
Yeah, they're called factors. Good. Factors, that's what we're going to be learning about today. Okay? When a repeated multiplication of equal factors can be expressed as a... when something's repeated, yeah. Janaine? Sorry, power, yeah. Is that what you said, power? Yeah. Can be called a power. So 3 to the exponent of 4, the whole term is called a power. The 3 is called the base. And what's the 4 called, RC? The 4 up here. Exponent, yeah. Alright, so those are the parts of a power. So an example, we're going to write each in expanded form and then evaluate to standard form. So if I rewrite this 6 cubed, I'm just going to rewrite the 6 3 times. 6 times 6 times 6. 6 times 6 is 36, times 6 I believe is 216. So standard form is just basically the answer in number format. Next we have 3 to the exponent of 2 times 2 to the exponent of 3. So if I were to rewrite this expanded, it would look like this. Remember when you have two numbers next to each other in brackets, that means multiplied. Okay, so if I solve this, it's 9 times 8, which is 72. All right, last one. We're going to have 6 times 6 plus 3 times 3. So we get 36 plus 9 equal to 45. Any questions with that basic exponent power math? All right, good. Now, power of a negative number. So exponents affects only the number it touches in a power. Can you see the difference? So here we go. Negative 3 squared. So because this negative sign is not included in brackets to the square, it stays on the outside. This is very important. It's going to get confusing quick if you start squaring the negative. Because it stays on the outside, the answer is negative 9. Now if it was like this, where the negative is part of the power, it's the base, you're going to get that negative sign gets multiplied by itself and you get positive 9. Okay? Very important that you understand why those two numbers are generating a different answer. Any questions there? All right, next. It says x minus 3 squared. We don't have to deal with the x or the negative in the square, so we can leave those out because the square is only attached to the 3, so it becomes x minus 9. All right? Exponent rules now. To multiply powers with the same base, what do you think we do to the exponents? You guys covered this before? Yeah? Did you? Yeah, we add them. Have you guys seen this before?
Yeah.
Where was this? Grade 9? Yeah, okay, good. M plus n. Here we would have x2 plus 3 is equal to x, the exponent of 5. Okay? When they have the same base and we're dividing the powers, what do, Adrian?
We subtract.
Yeah, we subtract. Okay, so this would be xm minus n. This would be x6 minus 2 would be x to the 4. Alright, to simplify a power of a power, keep the base the same. And what do we do with the exponent? So now we have a power that's raised to an exponent. What do you think, Andrew? Yeah. Okay, I said m times n. You actually wouldn't write the times because it would get confusing. You would just write xmn. Okay, and this would be x2 to the exponent 2 times 3, x to the exponent of 6. Any questions? So far, so good, right? We're going quick here. Beautiful. First page done. Second page. Write as a single power and then evaluate. Maxis, what would this be as a single power? Yeah, 4 to the power of 5. And if you use your calculator, you should be able to do this relatively easy and get 1024. Okay. Next, raising this to a single power, Douglas, 2, 2, 6, and then 2, 6 on your calculator is, I think it's 64. Yeah. All right. Adrian, 3 raised to what? Sorry? We got a 3 and a 2 here. Yeah, 3 plus 2 is 5. Okay, 3 raised to 5 is 108, I think. Is it? Oh, my bad. I missed that. Sorry, we would have to then evaluate these individually. You're right. So 3 to the exponent of 3 is 27 times 4. That's 108. Next, Jadane. 7 to the exponent of 3 divided by 7 to the exponent of 2. So I could rewrite it like this. What's that equal to?
7.
Jadane. Yeah, it's just 3 minus 2, right. So 7 to the exponent of 1, which we know is 7. Okay, Rudy. 10 to the exponent of 7 divided by 10 to the exponent of 4. What am I going to do with those exponents when I'm dividing the powers? Yep, 7 minus 4 is what? 3 is what? You know? 10 times 10 times 10? It's 1,000. Okay, it's 10 times 100. You're going to use your calculator if you don't know that, okay? This one, Jaden, 6 to the exponent of 2014 divided by 6 to the exponent of 2013. This is going to be equal to 6. Okay, next, Janier, this is what? No, don't give me the answer. Just give me what it is in the power form. It's going to be 2 to the exponent of what? 10, right. Now I think that's 1024. Okay, Josiah. 3 to the exponent of? Yep. Yep. And you're going to put that on your calculator. And what do we get? We got to get familiar with that exponent button for this whole section. 729? Sounds right. Last one. 4 to the exponent of, yeah, Ethan? Sorry? 3 times 2. Yeah, you got to multiply them when they're raised. What's 4 to the exponent of 6?
4096.
4096? Thanks. All right. 0 exponent. So what happens when we divide 5 by 5? The answer is 1. How about dividing 18 by 18? The answer is still 1. What happens when we divide a power by the same power? So 3 to the exponent of 6 divided by 6 to the exponent of 6. Using the exponent rule, we can subtract the exponents. We get 6 minus 6 is 0. Now we're left 3 to the exponent of 0. You remember that anything divided by itself is 1. You also realize that 3 to the exponent of 6 divided by 3 to the exponent of 6 is also 1. Okay, so there's the logic behind anything to the exponent of 0 is 1. It's the same thing as dividing itself by the same number, right? So just like if we had 10,063 divided by 10,063, we're going to get 1. So therefore, if a is not equal to 0, then a to the exponent of 0 is equal to 1. And this includes negatives, right? If we have negative 8 divided by negative 8, it's still going to be 1. Right? So 6 to the exponent of 0, Teodi, is going to be? Sorry? 1, yeah. Jafet, a to the exponent of 0. Yeah, 1. Even though I don't know what a is, I don't care. Because I know it's a divided by a. I know it's going to be 1. Okay, and then negative 3 to the exponent of 0 is just negative 3 over negative 3, so that is 1 as well. All right, moving right along. Negative exponents. Here we go. So negative exponents, when we have a negative exponent, we have to do what? Who remembers from the video? Yeah. What do we do? Jaden? Yeah, we flip it. Okay, let's see. So the first one here actually is not a negative exponent. It says 2 to the exponent of 3 divided by 2 to the exponent of 1. Okay, well, we know that that is 2 times 2 times 2 over 2. We know that's 4. We also know, using exponent law, 2 to the exponent of 3 minus 1 is equal to 2 squared, which is equal to 4. Okay, so this is not negative exponents quite yet. Or maybe it will be. Let's see. 2 to the exponent of 3 over 2 to the exponent of 2. Okay, when I have this, that's my expanded version. These will all divide into each other, and I'm left with 2. Okay, let's use our exponent law now. 2. All right. Here we have 2 over 3, 2 over 3. All of these cancel out, and I get 1. So 2, 3 minus 3 equals 2 to the exponent of 0, which is equal to 1. All right, next one. 2 to the exponent of 3, so I'm going to write that out. 3 of these cancel, so I get 1 over 2. Right, so we're going to do 2, 3 minus 4, which is 2 to the exponent of negative 1. And as we learned, when we have a negative, we flip it. So it becomes 1 over 2 to the exponent of 1, which is just 1/2. So we're getting the same value there. Next one, Alan. What am I going to do here? I'm dividing powers, so what do I do? First do the expanded, so what am I going to write out? 2 to the exponent of 3, I'm going to write what? No, 2 times 2 times 2, right? And then below here? Okay, and then 3 of these cancel out. They give me 1. So I have 1 over 4. 2 times 2 is 4. Now what am I going to write here, Alan? Yeah, equals? Okay, which is, when I flip it, 1 over 2 squared, which is 1 over 4. All right? Next one, Stefan. What am I going to write in expanded form? 2 to the exponent of 3. What am I going to write?
2 times 2 times 2.
Yep.
Divided by 2 times 2 times 2 times 2.
Yeah, 6 times. These all go. I'm left with 1 over 2 times 2 times 2, which is 1 over 8. Okay, now here, what do I write, Stefan? 2.
To the power of 3 minus 6.
Yep. Equals? What's 3 minus 6?
Negative 3.
Yep. Okay, so then I know it's 1 over 2 to the exponent of 3, which is 1 over 8.
Sure. Where did you get the ones from?
Here?
No, on the right.
Here?
Yeah.
Because when you flip a number, a whole number, it's 2 over 1, right?
Yeah.
But I'm flipping it, so it becomes 1 over 2. Okay? So any base raised to a negative exponent is equal to, and there's this fancy word here, reciprocal. Reciprocal of the base raised to the same positive exponent now. Change the sign to positive. Okay, so there is the law. A to the negative m is equal to 1 over a to the positive m. And a to the negative over a to the negative m becomes flipped a to the positive m. All right, example here. Maxis, rewrite each power with a positive exponent. Do not evaluate. How would I rewrite this? Sorry?
So would it then be like negative 7?
Nope.
11, positive 11 to the exponent?
Nope, not negative 7. We're not changing the sign. We're flipping it. So what is 7 over 1 flipped? What's the reciprocal?
7?
Yeah, 1 over 7. And then what's 7 raised to down here?
Sorry?
What's the exponent here?
7.
Sorry?
Oh, 11, sorry.
Come on, man, you got to pay attention. Lucas, you can do the next two. Negative 3 to the exponent of negative 4. What's the answer? 1 over negative 3, yeah? Very good. Next one, same thing, Lucas. 4 to the negative 7 over 4 to the negative 9. What am I going to do with the exponents? Subtract, so negative 7 minus 9. What's negative 7 minus 9? Negative 16, good. And so what is 4 to the exponent of negative 16? In positive exponents. Yeah, 1 over 4. Yes, very good. Okay, Andrew.
I'm not sure. So,
You want to get rid of the negative exponent. In order to do that, you need to flip the base. So what is 1 over 3 flipped?
1.3.
No? What is 1 over 3 flipped, the reciprocal?
3.
3. Okay, 3. Now you got rid of the negative, so it'll be to the exponent of?
128.
Yeah, that's it. Okay, Liam. Last one, the hardest one. You have a negative exponent, so we want to get rid of this. Get rid of this by flipping base. Okay, so what is this base flipped? Yeah, you're not going to change the negative because it's not the negative reciprocal, it's just the reciprocal. So unlike the right bisector or the slopes where we had two lines that are perpendicular, we use the negative reciprocal. Here we're just using the reciprocal, so you don't change the sign. And now what do I put to the exponent, Liam? Yeah. Any questions? Sweet, moving right along. Example 4. Use exponent laws to simplify each of the following, then evaluate the standard form. Okay. Where are we? Milkius. Give this a try. So 2 to the exponent of 3 times 2 to the exponent of 2. What am I going to do with those two exponents? They're multiplied, the two powers. So what do I do with the exponents? Yep. And then I can leave the denominator alone for now. So I'm going to get 2 to the exponent of 5 over 2 to the exponent of 6. So what's the answer going to be? What do I do now with the exponents? Right, so 5 minus 6 is? Good, 2 to the minus 1. So we know we want to get rid of the negative 1. So how do I get rid of it? Say it again? Yep. 1 over 2 to the exponent of 1. We don't need to show the 1. So it's just 1 over 2. Next. Let's go with Josiah. 3 to the exponent of 3. We can leave for now on the top, right? What am I going to do with these two powers on the bottom, Josiah? Yeah, so 4 times 2 is? 8, yep. Now 3 minus 8, right? Because we're dividing is what?
5.
Yeah, negative 5, right? And so then what do I do with this? How do I make the exponent positive?
Add it.
Nope. What do we do with the base when we have a negative exponent? We want to get rid of that negative. We've been doing it the whole time. Josiah, what do we do?
Oh, divide.
Nope. Reciprocal. Remember that word? Do you know what it means? What's the reciprocal of 3?
Flip it.
Yeah, you flip it. So what is 3 flipped? It's 3 over 1, right? So what would it be? 1 over 3, good. What exponent am I going to add on the 3?
5.
Yeah. Okay, and then we would have to do 3 to the exponent of 5. Oh, my bad. Hold on. I still have the 3 over 3 on top, right? No.
It's 4 plus 2, not you don't multiply, then you add them.
It would have been 6. My fault.
1 over 3 over 3.
My fault. Was that Josiah or me? I think that was me, right? My bad. Sorry, Josiah, I threw you off. So 3 over negative 3 would actually be 1 over 3, which is 1 over 27. Okay? Jeds, this one. Now you got 4 to the exponent of 5 raised to the exponent of 2. What do I do with the exponents now when they're raised to a different exponent? What do I do with them? Yeah, so 5 times 2 over 4 times 12. So what is 5 times 2? Good. Over 4, 12. Now what do I do when we're dividing the powers? Yeah, so what am I going to get? 4 to the exponent of? Negative 2. Now what do I do? Yep. Yeah. Good. Make sure when you flip, make sure that exponent comes down with the 4. Don't put the square up here. That'll mess you up. 1 over 16. All right. KG. 2 over 3 to the negative 3. So what can I do right away to get rid of this negative?
Reciprocal.
Yeah, reciprocal. So what's the reciprocal of 2/3?
3 over 2.
3 over 2. Now that's going to be raised to the exponent of? Okay. Now, I haven't covered this yet. When you have a fraction, the exponent that is covering that entire fraction, it belongs to the numerator and the denominator. Okay? I'm going to say it again. When you have a fraction, that exponent needs to go to both the numerator and the denominator. So this is the same as
When it's in the bracket.
this. Yeah, when it's in the bracket. Because you're cubing both the whole term. So you have to cube the top and the bottom.
So,
Yep.
what, 3 times 3 over 2 times 3. Is that like the finalized form?
Would it be what?
Should we just keep it in the brackets or should we keep it where both of them out?
No, because we want to evaluate it, right? We want to get a full answer. So it's going to be 27 over 8. Okay? Maxis. Sorry? Yeah. That's okay. It happens. All right. Maxis, while I got you, how are we going to get rid of this negative 2? Okay, am I going to change this negative sign? No. Good. So negative what? Good. Now this goes positive. Now, how do I deal with that square when I have a fraction? I just said it in the last example. Who does this square belong to? Up here, down here? Both, right. So this is extra tricky here. We have a negative sign. Now, this is going to confuse some of you. I just explained that the exponent belongs to both the top and the bottom. The negative sign only belongs to one. You can choose the bottom or the top. It always makes more sense to me to put it on the top, personally. It looks weird if it goes with the numerator, but because of that, this becomes negative 5 squared over positive 2 squared. Take a look at this example because it's getting confusing. Starting to get confusing. Anybody tell me why the negative has to go with either the numerator or the denominator? What would happen if we put it with both?
Wouldn't like become a positive then or something like that?
Yeah, it would change the sign. So really it has to go with one or the other. Okay? Now, it wouldn't change the sign in this case because it's squared. So a negative number times a negative number is positive. So if you actually put it with the 2, in this case you would have still got it right because we're going to get a positive answer here. We're going to get 25 over 4. But if you had an odd number exponent and you had a negative, that negative sign would have to show up only on either the numerator or the denominator. Let's just say, for argument's sake, always leave it on the numerator. So maybe when you write a fraction, like if I'm writing negative 2 over 5, maybe to avoid confusion, you write the negative sign with the numerator. I don't know. When you're expanding it. So this would be negative 2 over 5 times 5 times 5. Okay? See how this would change if it was the negative on the bottom as well? Because you'd then have negative 125 here. You'd have a negative value on top. They would divide and you'd get a positive value. Any questions about that? Nobody's confused there? All right, super duper. We're almost done. Into the word problems here. Half-life is the time it takes for a radioactive element to decay to half its original amount. You're going to see this a lot. They're going to have these questions in physics and chemistry next year. Determine the remaining mass of 300 milligrams after 8.4 days. So here we say the half-life is 4.2 and our mass of 300 milligrams after 8.4 days. Okay. The way we determine this is there's a formula. You're going to put the amount times, in this case, the half-life. So half raised to the exponent of 2. Okay, so this is going to work out to 75 milligrams. Okay, and the reason it's 2 here is because 8.4 is equal to 2 times 4.2. 12.6 is equal to 3 times 4.2. So their half-life formula then becomes 300 times a half to the exponent of 3. And we get 37.5 milligrams. Okay? For 21 days, that's equal to 5 times 4.2. So that means our formula becomes 300, our half-life, so it's a half, to the exponent of 5 equals 9.375 milligrams. Okay?
Sir,
Yep.
you multiply it by the half first and then do the exponent.
You say that again?
You multiply it by the half first and not by the half on the exponent.
Yes. And the exponent is based on what the half-life is. So if the half-life is 4.2, you have to determine 8.4 divided by 4.2. So you're seeing how many times it's been reduced by half.
So is that bed mass?
Bed mass?
Yeah. Are we using bed mass?
Yeah, well, you are, because you're dealing with this first before you multiply by the 300. Yeah. Okay, example 6. Culture of bacteria in biology lab contains 2,000 bacteria cells. On February 12th, the number of cells in the culture doubles every day. This can be expressed by the equation. So we have this equation, it's given to us. N, where N represents the number of bacteria, and T represents the time in days. So find the number of cells after 2 days and after 1 week. So after 2 days, you're going to take that 2 and you're going to substitute it in for T. So the number is going to be 2,000 times 2 to the exponent of T, which is equal to 2,000 times 2 to the exponent of 2. So this is 2 days. We're going to get 2,000 times 4, so we're going to get 8,000. And then after 7 days, we have the same formula. N equals 2,000 times 2 T, where T is 7. I think 64 times 2, so 128, I think, is equal to 256,000. All right? What does T equals 0 indicate? Yeah, you're right. You would get 1 for the time. So if we substituted that in, we would get 2,000, right? But what does it indicate? Basically when? When what? Couldn't hear you. Basically when time is 0, right? It's right at the beginning of the experiment. Okay? Time is 0. 0 days, that's what it means.